Hello everybody, welcome back to the workshop. So in this video I'm going to attempt to answer some of your questions here that you've had for me on YouTube across several different forge welding videos. I hope to answer those today. So let's get right into it, shall we? So the first question I'm going to answer, it came from 521 CJB, and he asked, dumb question, the kind I'm best at. I don't believe you're best at dumb questions. That's probably me. Everyone I've seen does a very light weld on the first heat, emphasizes light quick blows, then reheats the joint for more serious welding. Why not hammer it down hard on the first heat? That's a great question. So the reason why you don't want to take and hammer a weld hard on the first heat is for the fact that the two welding planes have become molten, okay? So you have molten metal there, but just underneath those two welding planes, you have unmolten metal. So if you whack it too hard on your first few hammer blows, what ends up happening is you squirt out all that liquefied metal or the two welded areas that was going to become fused together, and you come back down to bare metal, if you will. So this thing is, so it's not actually weldable at that point, and it doesn't stick. And you say, man, what the heck? And it's because you whacked it too darn hard. That's the reason why most smiths prefer to take little light taps just to take and push those two liquid surfaces, or molten surfaces I should say, to push those two together before they go on to more serious welding heats. This one came from Toby Joe 57. He asked, Roy, may I ask if it would be better as a novice or newbie to start with pure coke fire? So a great question. You do not need a pure coke fire, and in fact it can invoke a lot of its own difficulties. One, for instance, is to take and get it lit and to control the size of the fire, because you really need to take and control your airflow in order to take and control the size of your fire. So welding with just straight coke, although it's a very clean burning fuel because it's basically pure carbon at that point, it is a very clean burning fuel, but it could be a little more difficult to take and arrange things to where you can get a good welding fire. I suggest anybody to take and start with green coal. You may not have that in your local area, so you can do forge welding and get stuff up to proper temp. Even with a charcoal forge, we've been doing it for thousands upon thousands of years. So, the fuel substance isn't really an issue as far as difficulty range-wise. I say the green coal's a little easier to work with because it has a tendency to coke up or clink or clump together, which can provide you a nice little cave that you can stick your material in, and on occasion move a few pieces and look in at it, as where the coke is a little harder to do that, so I would suggest green coal. Next question. Any tips on controlling oxygen in a propane forged? Asked Vernon Armstrong. So, the tips for controlling the oxygen level in a propane forge, in a nutshell, is if you have yellow sulfurous kind of like flames, or like yellow sodium flares, if you will, some people call them that. That's not truly what it is, but if you see big, long, lofty yellow flames coming out of the front of the forge, you are usually running a little too oxygen rich. If you see blue flames running out of the front of the forge, that means you are running a bit fuel rich. The happy medium is right in between those 2 points. You don't want to have a lot of dragon's breath coming out of the front of your forge. You want all of the oxygen that's going into the forge and all of the fuel that's going into the forge to be consumed. So you won't have a big giant flame sticking out about this far. Everything, when you have it adjusted right, it should be back within 3 to 4 inches of the front opening of that gas forge. Now, that is what has been my observations for good optimum propane usage and to achieve a good welding heat that is an oxygen neutral environment. Next question comes from Guilty Spark. And he asks, can stainless steel be forge welded? To the best of my knowledge, I do not believe so, in the sense of it actually being in a forge, you bringing it up and you welding it like a traditional blacksmith would. I know stainless steel can be welded in many different forms, arc welded, a whole bunch of different stuff. It can actually be welded together. I'm not sure the environment that is needed to actually weld stainless. So for all intensive purposes, I would stay away from stainless and trying to weld it in a traditional sense like a blacksmith might. And that is just more for your own sanity. And if it's a certain grade of stainless, it can have a high chromium content in it. And that chromium, once it gets above a certain temperature, it can actually bake out of that stainless steel and get into your lungs, causing all sorts of other issues and wreaking havoc on your health. So it would be my suggestion to stay away from stainless if you can, or at least research some, I would research it real in depth on a lot of metallurgy books before you ever attempt it. Most likely with stainless, you're going to need an almost purely non-oxygenated environment. You might even have to be pumping the welded joint with argon or something else like that, or nitrogen, to be able to take and get something to weld. So too much of a mess for a traditional blacksmith forge. Another question, it wasn't really a question, it was more of a comment that I would like to address in this Q&A. This one was by J.S. Ferrier. Another myth is needing a scarf to get a weld. I fire weld often with no scarf. I also believe you do need flux in a gas fire, but not always for a coke fire. So in a gas forge fire, the environment is different. I have been able to weld successfully without any flux whatsoever. It is my understanding on flux, from everything that I've found out about it, that it is of a boric acid and it eats away the surface material at high temperatures. It becomes more of an acidic at a higher temperature, and that's why it's a laundry booster. It's kind of an acidic in nature. It's supposed to break down some of those greases or whatever may be on your clothes, right? It's meant to be a laundry booster. But that boric acid, it eats out the layer of scale, and what that allows it to do is through capillary action, it wicks away the scale away from the two molten surfaces to be welded. It is not a sugar coating. It's not a plasticine. You're not, wrapping it in a blanket of flux and it's preventing all oxygen from getting to the surface of the steel or the material. It may have some little bit of benefits that way, but using too much flux will end up causing your welds not to stick. It will actually inhibit it because you've got too much of a layer build up and you could never whack it hard enough to get down to them unfluxed layers that are supposed to be molten. To address the scarves, the reason why you want scarves, or it's traditionally accepted to take and do scarves, is for this one simple fact. If you do not scarf your work and you lay things flat on flat like this and you forge them into each other, what ends up happening is you create two shear planes or two stress risers at the end of those joints. It pushes more down and cuts in. It kind of shears off the material. I'll try to show this in some other upcoming videos here soon and really demonstrate it. Maybe you can do a cutaway and etch it so this way you guys can see what I'm talking about here with the sharp. The purpose of putting a scarf on the end of a bar is putting that scarf helps reduce the area of the shear plane and therefore flatten it out into a welding plane. Mark Asbury did a wonderful video on this. I will put a link to it in the description down below and one up here where he went into real good detail and drawings about a welding and a shear plane. I suggest you watch that. It is very informative and it kind of makes up the purpose of the scarves. But moreover to J.S. Ferrier's point, no, in order to weld you don't need a scarf. You can lay two pieces of steel on top of each other, just like in the instance of Damascus work, and you can just weld them right up. They're not scarfed together. There's no goofiness going on there. It's just flat steel, stacked on top of each other. So as long as the surfaces won't trap scale, it welds up fine and you've got a useful billet. So another great question. Thank you for putting that comment out there, JS Farrier. I appreciate that. Next question comes from Robert Merrick. Can you do a quick add-on video on forge welding in a gas forge? Secondly, I just picked up a forge, but I don't have a building yet. Do I need to be inside or just shaded? Robert Merrick, thank you for the great question. So I do plan on doing a video at some point on forge welding in a gas forge, although that is not my preferred form of forge welding, as I am much more competent at forge welding in a coal forge. I would like to, however, point you to John Switzer, card right there, over at Black Bear Forge. He has done several videos around forge welding, and he talks a lot about forge welding in his gas forge, that he seems to have a lot of success doing axes and adze, welding in bits and things like that. I really highly suggest you go check him out. In the meantime, till I get around making my version of the same story of welding in a gas forge. But I can tell you how that video will basically be summed up. Make sure that you have your oxygen to fuel ratio correct. Make sure that you have a properly insulated forge that can achieve welding heat, and then you should be just fine. Also, you asked, let's see here, you just picked up a forge, but you don't have a building yet. Do you need to be inside or just shaded? Weather, climate permitting, you can be outside all you like. There's nothing to be a problem there unless your neighbors may be bugged by some of the sounds. Sometimes it's nice to have a bit of an insulated building to take and stop some of the hammering reverberations coming from the hammer and anvil. That's a great way of kind of making your neighbors happy with you. If you're out in the country, you could be under a sprawling chestnut tree. Again, blacksmiths have been doing stuff like this in hodgepodge locations for at least 12,000 years of recorded human history. So yeah, you don't need a building per se, but it sure is nice, especially when snow is upon you. You'll be a little less worried about that shade tree and a little more worried about those 50-mile-an-hour wind gusts, -30 wind chill, and ice stuck to the side of your face. Been there, done that. So that'd be it for that. Next comment on this one video that I did a video on 3 big myths about forge welding. This video actually came in from John Switzer over at Black Bear Forge. Again, check his channel down in the description down below and go check out him and go subscribe. But he had posed a comment. One of the reasons you are oxidizing and burning is because the clinker does not consume oxygen and results in an oxidizing fire. Clinker also doesn't contribute to the heat, but instead robs heat from your fire that requires you to turn up the air blast, which also contributes to oxidizing as opposed to being able to maintain a neutral or reducing fire. Kind of like turning the shielding gas on or off on your MIG welder. So thank you, John Switzer over at Black Bear Forge. Great comment, and yes, you are correct. That is something that I didn't go real deep into as I was trying to take and highlight around the myth of clinkers prevent you from welding. The myth about clinkers preventing you from welding is that the clinkers, they blow up against your metal, they somehow get into your joint, and they prevent you from making a good forge weld. And my counter argument to that was that the fact that it's the oxygen that's in the firebox, in the fire pot, that is actually creating the problem with you being able to get welds to stick and too much flux. So that was the main purpose of that video, but he is 100% correct on that. The more of a clinker that you have in the bottom of your forge fire when you're working with coke or you're working with coal, the larger the clinker is down there, the harder it is to get oxygen up to get the fire hot enough that it can come up to them welding temperatures for you to be able to create and establish a really good reducing fire to make a nice clean forge weld. Also having that in there, again, putting excess oxygen in there is putting excess scale on your piece, and so therefore that is going to take and blister your steel, or if not, burn the material itself. That's where you get all that sparkling happening. That is one of the problems that will occur if you have too big of a clinker in the bottom of the fire pot. So that is 100% correct. It's all about getting that nice neutral, not too rich in oxygen, not too rich in fuel, because if it's too rich in fuel on a coal forge, it's not at heat. If it's too rich in oxygen in a coal forge, it's going to overheat, it's going to overtemp and end up burning your steel. With the oxygen is what burns the steel. It is not the heat that burns the steel. So yes, very correct. If you have a big lump of a clinker in there, that's a bad deal. I'll put a link in the description to where I talked about how to remove the clinker mid-forging heat. I'll put a link down in the description as well. And for those of you who don't know where the description is, just take and click the little down, it looks like a little downwards triangle at the bottom right-hand side of your screen if you're on mobile. I think it's the same place if you're on laptop or something like that. Click on that and you'll be able to drop down the menu or the description menu and take a look down there for all these good links and stuff. I'm going to finish it off on John Switzer's comment there. I think I've answered enough in this video. If you have additional comments or if you have additional questions, drop them in the comment section down below and I will try to get to them in a follow-up video, or I'll try to add them on during my forge welding series. So one of the last things that I want to leave you with today is a bit of encouragement. Forge welding is not a mystery. It is a fundamental process of blacksmithing. And the key word there is process, and the other key word is fundamental. The process refers to the fact that you need to take and be able to go through certain steps to achieve a good weld on your material. And once you get all those steps in the right order and you have orchestrated them properly, you will have no problem sticking every single forge weld that you go after. The things that inhibit you from getting good forge welds is when you get those steps out of order, when they're all out of order and they're jumbled up like most beginners do, or when you're demonstrating and you're putting too much time and thought into explaining things, like I have done on camera before, you forget to pay attention to the metal and that you have done every best practice you could to make that a successful weld. So it is a process, and since it's a process, that means there's nobody out there who can't forge weld. I see that a lot of times from beginners or even more experienced smiths that never really learned to forge weld. They said, oh, well, no, I gave up on that a long time ago. I just can't forge weld to save my life. And that is more of a cop-out, and it's because they didn't have success, they got the process out of order, and then they can't forge weld. It's kind of like saying, I can't MIG weld to save my life. No, you just haven't took and turned on the argon bottle. You didn't set your amperage and your wire speed to the proper settings, or you didn't have that knowledge, and then therefore you couldn't weld. So obviously, well, I just can't MIG weld. No, it is a process. So forge welding, it's an ancient process. It's been done for thousands upon thousands of years, and you can do it as well. So that's it for this video. Hope you enjoyed it. As always, God bless you, and we'll catch you on the next one. Thanks for watching.